Welcome to the Deep Dive, a place where all hell breaks loose with A and Sayo.
That is, yeah, that's a pretty good way to put it right now. Maybe slightly terrifying, but accurate.
Terrifyingly accurate, maybe.
Maybe. But we're definitely way beyond just, another algorithm update here.
Oh, absolutely. It feels like a whole new layer has just appeared, right?
Yeah.
Sitting between the searcher and the website.
Exactly. It's this intermediary layer, and it's completely shattered that feedback loop we relied on for, well, decades.
Yeah, the old cycle was so comfortable, wasn't it? Optimize the page, watch it rank, track the click. Done.
Simple. Reliable.
And now, AI assistants are summarizing, citing, answering the question before anyone even gets a chance to click a blue link. That scoreboard, it's dissolving.
It really is. So our mission today, with this great set of sources you've pulled together, is to cut through that confusion.
Give everyone the shortcut to understanding what's actually happening.
Right. And we're tackling it in two main parts.
Okay, lay it out for us.
First, we'll cover the surface level stuff, the practical changes marketers are seeing right now, the confusing data, the, frankly, shocking lack of agreement between AI tools.
And crucially, the new ways you actually need to measure visibility, because old rankings, they just don't cut it anymore.
They're not on their own, no. And then second part, we go deep. We look under the hood.
Into the engineering, the tech that's actually driving all this.
Exactly. We need to get our heads around things like hybrid retrieval systems, how machines mix keyword matching with, understanding meaning.
And these new LM agents, the efficiency stuff sounds kind of mind-boggling.
It is. They're learning complex stuff faster and cheaper than most people expected.
So the sources today really blend everything. We've got marketing experts on measurement, deep dives into retrieval tech.
And even cutting-edge academic papers on how these AI agents are actually trained. It's a fantastic synthesis.
All right, let's not waste any time then. Let's unpack this fragmented new reality. Where do we start?
We start with the data that should make everyone sit up and rethink their strategy immediately. The new scoreboard, or maybe the lack of one. Okay, so if the old scoreboard's broken, we need a new way to understand what's happening. And the data from recent studies, looking at thousands of real queries across the main AI platforms, it gives us a pretty stark starting point.
And this is the big number, the one that needs to be front and center.
This is the headline finding. There's a massive lack of consensus out there. The research shows Google AI Overviews, or AIO, Google's AI mode, and ChatGPT. They recommend different brands almost 62% of the time.
Wait, 62%?
62%.
That's staggering. What does that even mean strategically?
It means fragmentation. Huge fragmentation. Think about it. A customer searches for something, and there's only about a 1 in 3 chance, 33.5% to be exact, that all three of these major AI platforms will point them to the same brands.
So if you're a brand and you're putting all your effort into optimizing for just one of them,
you're basically ignoring 2/3 of the AI conversation that's happening about your market. Willfully ignoring it.
it forces you then to stop thinking of AI as this single thing. It's not a monolith.
Not at all. And the sources make it really clear these platforms have, well, distinct personalities.
Yeah.
Preferences, reflecting how they're built, how they use data, how they're trained.
Okay, let's sketch out these personalities. What's Google AI Overviews, AIO like?
AIO. Its behavior leans towards breadth, volume. It's kind of a content collector. The data shows it cites brands way more often than ChatGPT, about 2.5 times more.
Wow.
Yeah, it averages just over 6 brand mentions per query. Seems like its goal is often that comprehensive, wide-ranging answer pulling from lots of sources. Very Google-like, wanting informational completeness.
Okay, so AIO is the collector. What about ChatGPT?
ChatGPT is much more selective. Its roots are deep in that massive foundational model, the historical data it was trained on.
Right, it remembers things.
Exactly. It only averages about 2.37 brand mentions per query. And because its knowledge is mostly from that internal model, it tends to favor established, well-documented brands. Entities it knows well from its training.
Even if it's not checking live search results for that query.
Sometimes, yeah. It acts like a librarian recalling the most famous books on a topic, defaulting to what's strongest in its memory.
Okay, and the third one, Google AI mode.
AI mode seems to be the most discerning. It has the highest quality threshold, it seems. It recommends brands less often than AIO or ChatGPT.
More selective.
Very selective. But when it does pick a brand, that brand usually gets really strong citation backing. It suggests it needs a high confidence score, maybe in factual accuracy, before it names names.
So collector, librarian, and discerning critic.
Something like that. But this fragmentation, the selectivity, it isn't totally random. The studies found really clear patterns, these contextual triggers, especially around commercial intent.
So this connects back to traditional SEO. Intent is still key.
Absolutely. If the query clearly signals someone wants to buy something, using words like buy, where, deals, pricing, then boom, the AI platforms mention brands about 65% of the time.
Regardless of which platform.
Regardless, the systems seem hardwired to switch from just giving information to facilitating a transaction when the user signals they're ready.
Does that hold true for specific industries?
Definitely. Look at e-commerce or finance. They consistently get 40% or more brand coverage in AI answers. The platforms are good at understanding that looking for a product or a financial service inherently means you're probably looking for a brand.
They know the user wants a who, not just a what.
Precisely. They're geared up to answer, which brand should I pick, when money's on the table.
Even for comparison searches, like best running shoes.
Even then, those best queries get brand citations about 43% of the time across all three. So if you sell stuff, the AIs will name brands. They just argue about which ones.
Which leads us to this big debate in the sources, right? When an LLM picks a brand, is it seeing authority like we used to think of it, links, domain age, trust signals?
Or is it something more technical? More about the underlying data?
This really flips the script on decades of SEO thinking, doesn't it? The argument is that what looks like authority to us might just be a side effect of the training data itself.
Exactly. It's likely a function of three things baked into that data. When ChatGPT pulls a brand name from memory, without a live link, it's not doing an SEO check. It's retrieving the entity most strongly tied mathematically to that topic in its internal map of the world.
And those three technical drivers are frequency, prominence, and embedding strength. Let's break those down.
Okay. Frequency is the most straightforward. How many times did your brand name pop up in the giant pile of text they trained it on?
More mentions equals stronger signal.
Basically, yeah. A billion mentions in high-quality docs makes you a stronger candidate than 10,000 mentions. Volume counts in training.
Makes sense. What about prominence?
Prominence is about where it was mentioned. Was it in a headline, a main topic, or just buried in a footnote?
So being central to the discussion matters more.
Right. A prominent mention leaves a stronger imprint in the model structure. It's about being part of the core narrative, not just a side note.
And the last one, contextual embedding strength. This sounds more abstract.
It is, but it might be the most important. It's about the mathematical closeness. How tightly is your brand associated with specific concepts in the model's high-dimensional space?
Give me an example.
Okay, say brand X is always mentioned right next to terms like high-yield savings and federally insured in the training data. The mathematical link, the embedding between brand X and the concept of safe banking, becomes incredibly strong.
So when someone asks about safe banking,
That tight connection makes the AI highly likely to generate brand X because mathematically they're neighbors.
hold on though, let me push back on that. Are you saying a strong mention from like 10 years ago, buried in that training data, could be more powerful than my perfectly optimized page that ranks #1 on Google today?
That's the tension. That's why we see that 62% disagreement.
Because they're using different signals.
Exactly. Traditional SEO is about live signals, links, speed, freshness, keywords now. But AI discovery, especially the ChatGPT style, is heavily influenced by foundational knowledge, signals the historical strength of association built during training.
So an established brand with a massive historical footprint has an advantage, even if a new disruptor has a better current SEO.
It can, yeah. The AI might default to the entity with the strongest historical mathematical tie, making it harder for newcomers to break through purely on current optimization.
Wow. So the game isn't just about winning the ranking today, it's about becoming the definitive semantic fingerprint for your topic in the AI's long-term memory.
You're optimizing for the history books the AI reads, not just the current search engine results page. It's a fundamental shift. Okay, so if we want to succeed in this new world, we have to understand how the content actually gets selected. How does an AI like Google AIO blend that historical knowledge with what's on the web right now? That's where hybrid retrieval comes in.
Right. So when you ask an AI that uses current data, it's actually running two different searches simultaneously.
Pretty much. Two separate methods looking for content in fundamentally different ways. And yeah, they often disagree.
What's the first method? The familiar one.
That's lexical retrieval. Think traditional search algorithms like BM25. It's been the engine behind search for ages.
Good old keyword matching.
Exactly. It's great at finding pages with the exact words or phrases you typed. If you search black leather gloves with buckle, BM25 nails it.
But its weaknesses.
It misses synonyms. If the page says dark cowhide hand coverings with clasp, BM25 might miss it entirely, even if the meaning is identical. It's precise, but narrow.
Okay, so that's method one. What's the other? The AI-driven one.
That's semantic retrieval. This totally ignores exact words. Instead, it maps the meaning. It uses embeddings, these complex mathematical fingerprints, for both your query and the documents.
Conceptual fingerprints. I like that.
Yeah, and then it sorts the results based on distance math. How close is the concept in your query to the concept in the document?
So this one can find synonyms.
Absolutely. You search warm hand coverings for winter, and it will find the black leather gloves page because the meaning lines up. It's flexible.
But it must have a downside, too.
It can be imprecise sometimes. It might connect two ideas that use similar words but are actually unrelated just because their embeddings are kind of close. It can overgeneralize.
Okay, so you have one list from keywords, precise but narrow, and one list from meaning, flexible but potentially fuzzy.
Yeah.
How does the system decide which one to use?
It doesn't choose one. It uses both. It needs a way to fuse those two ranked lists into one final balanced list.
And that fusion mechanism is?
Reciprocal rank fusion, or RRF. This is the logic sitting inside most modern hybrid systems, from Google to Azure AI Search, Elastic, OpenSearch. It's becoming standard.
And what's the goal of RRF?
To give the most credit, the highest score, to documents that do well in both worlds. Documents that are good matches based on keywords and based on meaning.
How does it actually calculate that score?
The core formula is surprisingly simple. Score equals 1 divided by a K plus rank.
Okay, 1 over K plus rank. What's K?
K is just a constant, usually around 60 in big systems. It's a smoothing factor, stops the hashtag 1 rank from totally dominating the score compared to hashtag 2 or hashtag 3. It helps balance things out.
And the rank is just its position in that specific list, like hashtag 1 in lexical, hashtag 3 in semantic.
Exactly. And here's the key part. If a document shows up in both the lexical list and the semantic list, you just add its two scores together to get its final RRF score.
Ah, okay. Let's use that example from the sources to make it concrete. They used K10 just to keep the math easy.
Right, so imagine two documents. Document A is brilliantly keyword optimized. It hits hashtag 1 in the traditional BM25 lexical search. But maybe its structure isn't great for AI understanding, so it only ranks hashtag 3 in the semantic vector search.
Okay, so BM25 rank 1, vector rank 3. What's its RRF score with K10?
Its BM25 score is 1 divided by 10 plus 1, which is 0.0909.
Got it.
Its vector score is 1 divided by 10 plus 3, which is 0.0769.
Okay.
Add them together. Document A's total RRS score is 0.1678.
All right, 0.1678 for document A. Now what about document B? Let's say it's slightly less keyword perfect, ranks hashtag 2 in BM25.
Okay, BM25 ranked 2, but maybe document B has amazing structure, super clear, perfect for AI, so it ranks hashtag 1 in the semantic vector list.
So BM25 rank 2, vector rank 1, what's its score?
BM25 score, 1 divided by 10 plus 2 equals 0.083 vector score. 1 divided by 10 plus 1 equals 0.0909.
Okay.
Add those up. Document B gets a total RF score of 0.1742.
Whoa, so document B wins, even though document A was number 1 in the traditional keyword ranking.
Document B wins because it performed well in both systems. Its high rank in both lexical and semantic searches gave it the edge overall.
That's huge. That really shows you can't just focus on one type of optimization anymore. You need both keyword relevance and semantic clarity.
Precisely. Optimizing only for keywords or only for concepts is not enough in a hybrid world. You need strength across the board.
Okay, that makes total sense conceptually. But here's the practical problem for marketers, right? We can't actually see those internal RRF scores. Google, ChatGPT, they don't publish that.
Exactly. It's proprietary. So how do you measure if you're doing well in this invisible system?
What's the workaround?
We have to use external observation, what the sources call diagnostic math, basically proxy metrics to estimate what's happening.
Okay.
The idea is you run a set of maybe 10, 20 critical queries for your business, and you compare Google's regular top 10 results with what the AI assistant actually cites in its answer. Then you calculate 3 key metrics based on the overlap or lack thereof.
All right, metric number 1.
Shared visibility rate, SVR. This is simple. Count how many URLs appear in both the Google Top 10 and the AI citations. That's the intersection I. Divide I by 10.
So SVR equals intersection 10. What does that tell you?
It measures agreement, alignment. How much does the AI trust what Google already ranks highly? A high SVR means the AI generally agrees with Google's signals. Your content is probably good for both keywords and meaning.
And a low SVR.
A low SVR means the AI is ignoring the top Google results. It suggests a mismatch. What Google's crawlers like isn't what the LLM finds useful or clear. Big red flag.
Okay, SVR measures overlap. What's the second metric?
Unique Assistant Visibility Rate, UAVR. This looks at the new stuff the AI introduces. Count the citations that are only in the AI's answer, not in the Google Top 10. That's novelty. N. Divide N by the total number of citations the AI gave.
UAVR, novelty total AI citations. What's this measuring?
The AI's independence. How much is it going off script from Google's Top 10? A high UAVR means the AI is finding valuable content from sources Google isn't ranking high.
Why would it do that?
Often because those unique sources, while maybe lacking traditional link authority, are just better structured, clearer, more semantically sound. This is a huge opportunity for newer brands bypass the old hierarchy with semantic excellence.
Interesting. Okay, one more metric.
Repeat citation count, RCC. This tracks consistency. For your set of test queries, how often does the same domain get cited again and again in different AI answers? You sum up how many times your domain was cited across all queries and divide by the number of queries you tested.
RCC, total citations for my domain number of queries. So this shows reliability, trust.
Yeah, reflects semantic consistency. If the AI keeps coming back to your domain for related topics, it suggests your content is considered authoritative or very well aligned with those concepts in its training or understanding.
Okay, so we have these three diagnostic numbers,
Yeah.
SVR, UAVR, RCC. How do we use them to decide what to do?
You look at the combination. For example, say you run your queries and find you have a low SVR but a high UAVR. What does that diagnose?
Low SVR. AI disagrees with Google's top 10. High UAVR. AI is finding other stuff it likes better.
Exactly. So the actionable insight isn't necessarily get more backlinks. It's probably fix your content architecture. The stuff ranking high on Google might be great for keywords, lexical, but it's failing semantically. Too dense, maybe, no structured data, too ambiguous.
Ah, okay. What about another combo? Say moderate SVR, but a really high RCC for my own domain.
Moderate SVR means some agreement with Google. High RCC means the AI consistently likes citing your domain. So semantically, you're strong, the AI trusts you.
Right.
But maybe you're weak on the lexical side. Your traditional SEO could be better. So the tactic shifts. Improve headings, internal linking, keyword focus. Help the BM25 side of RRF give you a boost.
Got it. So these metrics aren't just numbers, they're diagnostic tools pointing towards specific optimization strategies, either structure or traditional SEO or both.
Exactly. It moves us from just chasing rankings to optimizing the underlying content architecture for this new hybrid reality.
Okay, we've covered the messy scoreboard and the hybrid system picking the content. Now let's talk about the brain doing the work, these large language model agents.
Right. The systems generating these complex AI overviews or ChatGPT responses aren't just simple text predictors anymore. They're increasingly powered by these sophisticated LLM agents.
They're more than just chatbots.
Much more. Think of them as active problem solvers. They often use frameworks like REACT, which stands for Reasoning Action Observation.
Reason, act, observe. How does that work?
They break down a complex task like summarize the best laptops for students under $500 into steps. They reason about what information they need first, then they act, maybe using a tool like a search engine or a price checker, then they observe the results. Then they reason again based on that new info, maybe refine their plan and act again. It's an iterative loop.
So they're like little autonomous researchers using tools.
Exactly, intelligent automatons. But there's a huge catch, the cost problem.
Ah, these things are expensive to run.
Extremely. The really good ones, the agents that can do complex reasoning, usually rely on the biggest, most powerful LLMs out there. Think GPT-4 level models.
Yeah.
And a complex task might need dozens of those reasoning loops, dozens of calls to that massive model, crippling costs and high latency. If every detailed answer costs, say, $10 in API fees and takes 30 seconds, you can't deploy that widely.
Yeah.
It's just not economically viable at scale.
Okay, so how do the engineers get around that? Make it cheaper?
The solution is agent distillation. The basic idea is to transfer the skills, the reasoning capabilities, from that huge, expensive teacher model, let's call it by KeyEye, to a much smaller, faster, cheaper student model.
Like teaching the smarts to a more efficient apprentice.
That's a great analogy.
Ah.
If you can get the small model to perform almost as well as the giant one, you slash the cost and latency, making widespread deployment possible.
How did they used to do this, the traditional method?
Traditionally, they use something called behavior cloning, BC. It's pretty straightforward. The student model just watches the teacher model solve the problem step by step and tries to imitate that exact solution path.
Learn by copying sounds reasonable.
It sounds reasonable, but the sources highlight a massive problem with it, especially for complex, multi-step reasoning tasks.
What goes wrong?
It boils down to knowledge gaps and reasoning errors. The small student model isn't as smart as the teacher, so inevitably it makes a small mistake somewhere along the way.
Okay.
But because these tasks are sequential, one step depends on the last, that tiny initial error throws the student into a state that it never saw during training. It's off the rails.
And that leads to...
Compounding errors. That first small mistake leads to another, slightly bigger mistake, which leads to another. And the errors grow quadratically with the length of the task, the horizon h. The total error blows up as Josley epsilon quadratic growth.
That sounds bad. Can you give an analogy?
Yeah, imagine you're programming a Mars rover's 100-step landing sequence. Behavior cloning is like copying a perfect sequence. But if your rover makes a tiny 1% navigation error on step 1, by step 100, because of that 2H22 compounding, the error isn't just 1% bigger, it's exploded. You miss Mars entirely.
Catastrophic failure from a small initial slip-up.
Guaranteed failure, essentially, for long, complex tasks. Standard behavior cloning just isn't stable enough for teaching complex reasoning.
So if BC doesn't work well, what's the breakthrough?
The new research highlights a framework called SCORE, student-centered one-step reinforcement, and it totally flips the teaching dynamic.
Student-centered, how does it change things?
It changes when and how the teacher helps. The core idea is called mentored problem solving, MPS.
Okay, mentored problem solving, what's the process?
Instead of the teacher doing the whole thing first, the student tries to solve the entire complex task on its own.
Okay, student takes the lead, then what?
The teacher just watches. And only if, or rather when, the student makes an error, the teacher steps in. But, and this is key, the teacher provides only a minimal single-step correction right at the very first point the student went wrong.
Just fixes that one mistake.
Exactly. Like a human tutor watching a student code. If they mess up line 5, the tutor doesn't rewrite the whole program. They just say, try this for line 5. And then the student takes over again and continues reasoning from that corrected point.
That sounds intuitively much better. What are the advantages?
It has 3 massive technical benefits according to the research. First, capability matching. The student is always working on problems that are right at the edge of its current abilities. You're not making it relearn stuff it already knows. You're targeting the training right where it's needed.
Efficient teaching. Makes sense. Second,
deficiency localization. Because the correction happens at the exact point of failure, the training signal explicitly pinpoints the student's specific weakness. It gets a clear example of, don't do X, do Y instead, right when it matters. Very focused feedback.
Okay. And the third advantage must relate to those compounding errors.
Absolutely. This is the killer advantage. By correcting the first error immediately, you stop that whole chain reaction of mistakes from ever starting. You truncate the error propagation.
So the error growth goes from quadratic
down to linear growth, from so on. Small errors still happen, but they don't snowball catastrophically. They just accumulate additively.
Right.
This makes training stable even for very long, complex reasoning tasks. It's a huge efficiency gain.
Linear versus quadratic error growth. That's the key to making this distillation actually work for complex agents.
Precisely. But SCORE doesn't stop there. After this initial training phase, using the corrected examples that's called supervised fine-tuning, or SFT, it moves to a reinforcement learning RL phase.
Why RL? Isn't the mentored correction enough?
The mentored correction fixes errors, but RL helps the student achieve true mastery learning to find the optimal path independently, not just avoid mistakes. And SCORE's RL phase has 2 clever innovations tailored for agents.
Okay, what are they?
First, short horizon rollouts. Traditional RL often starts the agent for the very beginning of the task every time it tries to learn. This can be really inefficient and unstable, especially if the task is long.
So SCORE does.
It starts the RL rollout from the verified prefix right after the point where the teacher made the correction in the earlier phase. It focuses the learning effort only on the tricky part where the student failed, shortening the horizon and making the learning process much more stable and efficient.
Focuses the compute power. Smart.
Oh.
What's the second RL innovation?
Key step rewards. Standard RL often has a sparse reward problem. The agent only gets a reward, like a 1, at the very end if the entire complex task was successful and 0 otherwise. It's hard to learn from just that.
Like only getting graded on the final answer, not the steps.
Exactly. So score adds extra immediate rewards at the point where the correction happened. It gives a bigger bonus if the student successfully reproduces the teacher's correct step, and a smaller bonus just for avoiding the original error it made.
Ah, so gets credit for learning the crucial step. Solves the sparse reward issue.
It provides much richer, more immediate feedback, guiding the student more effectively towards mastery.
And the results. Did the score framework actually work?
The results in the paper are pretty stunning. Using this whole pipeline MPS for the initial data, correction-based SFT, and this specialized RL, they managed to get a small 7 billion parameter student model
Like Quen 2.57b instruct, one of the examples.
to match the complex reasoning performance of its massive 72 billion parameter teacher model on tough benchmarks.
Wow, a 7b matching a 72b.
Yeah, hitting scores like 50.8 average on reasoning tasks, which was over 8 points higher than what they got using standard behavior cloning. It's a massive leap in distillation efficiency.
So this is the engine under the hood becoming incredibly efficient. Small, cheap models getting the reasoning power of giants.
That's the takeaway. It's not just about slightly lower API costs. It fundamentally changes the economics. It means these highly capable AI agents can, and likely will, be deployed much more widely and quickly than we thought.
Okay, so let's pull this all together. We've got this fragmented landscape, the 62% disagreement. It's driven by hybrid retrieval, RRF, balancing keywords and meaning. And it's powered by these hyper-efficient new score-trained agents.
It's a complex picture.
So for the person listening, the marketer, the content creator, what's the actual path forward? What do we do?
The strategic opportunity, the clear path that emerges from all this, is creating content that works everywhere. Content optimized for both lexical search, the BM25 keyword side, and semantic AI discovery, the embedding meaning side.
And the common ground, the language both systems understand, seems to be.
Structure. Clear, logical, unambiguous structure. That's what helps both the old crawlers and the new LLMs make sense of your content.
The sources get pretty specific about actionable on-page steps for this hybrid world, right?
They do. It's about making your content easy to digest, easy to chunk up, easy to reference, and easy to verify for these systems.
Okay, what's step one? Writing style.
Yeah, move away from long, rambling paragraphs. The advice is to write in shorter, distinct claim and evidence blocks. Think 200, 300 words per block.
Why that structure?
It makes the content highly chunkable. Easy for an AI to grab a specific claim and its supporting evidence accurately without getting lost trying to summarize a huge, complex section. Reduces the risk of misinterpretation during paraphrasing.
Okay, short, focus blocks. What else?
Reinforce the obvious structural markers. Use clear H2s, H3s, use bullet points, numbered lists. But a key point for the hybrid aspect, use stable anchors.
Stable anchor text in links. Why is that so important?
That's your nod to the lexical side, to BM25. Those stable descriptive anchors help the keyword algorithm quickly find and rank specific terms within your page, boosting that lexical score needed for RRF. Don't just use click here.
Got it. Be descriptive for the keyword side. What about making the meaning clearer for the semantic side?
Formalize your structure with schema markup. Add relevant types like FAQ page, how-to, product, tech article, whatever fits. This isn't just for fancy snippets anymore.
How does schema help the AI?
It explicitly tells the vector models and the AI agents the context and the type of information they're looking at. It removes the ambiguity far better than just raw text can. Is this a question? A product spec? A step-by-step guide? Schema clarifies that.
Reducing misinterpretation again? What about trust signals?
Also important, keep your canonical URLs stable. Don't change them unnecessarily. And clearly timestamp content updates. These signals help AI agents verify the freshness and stability of the information.
And there's a specific point about PDFs.
Yeah, for certain types of content high-trust stuff, like technical papers, legal documents, detailed specs, consider publishing a canonical PDF version alongside the HTML.
Why PDFs?
AI assistants often seem to prioritize citing fixed, verifiable document formats. A PDF feels like a stable, published artifact, potentially increasing its trustworthiness as a citation source compared to an easily editable web page.
Okay, all these structural recommendations, short blocks, headings, anchors, schema, stable URLs, maybe PDFs, they all point towards making the content incredibly clear. Why is that clarity so vital for AI?
It comes down to the core weakness of current LLMs, handling semantic ambiguity.
Explain that. Semantic ambiguity.
It's a basic linguistic idea. Words, phrases, sentences can often have multiple meanings. The bank is closed. Which bank? Riverbank. Money bank.
Humies figure it out from context, usually.
Exactly. We infer. We use world knowledge. Ambiguity actually makes human language rich and efficient. But for machines, it's a major hazard.
Why is it so hard for AI?
The sources emphasize that current AI often lacks that deep, nuanced inferential ability. It struggles to reliably pick the right meaning when faced with ambiguity. If your paragraph mixes three related but distinct ideas using similar words.
The AI might connect the wrong dots. Or just get confused and cite something else entirely.
Precisely. It might grab the wrong snippet, generate a subtly incorrect summary, or just skip your content to avoid making a mistake, a hallucination. Ambiguity increases citation risk.
So the reason for all this focus on structure, the clear headings, the short blocks, the schema, is fundamentally about reducing that semantic ambiguity.
Yes, you're making it as easy as possible for the machine to understand exactly what each piece of your content is about, minimizing the chances it gets confused or makes a bad connection. You're lowering the interpretation risk.
Makes perfect sense. Structure equals clarity equals lower risk for the AI.
And when you achieve that clarity, that low ambiguity, that strong structure, it enables something really powerful, the citation network effect.
What's that?
It's the idea that success breeds success in this fragmented AI ecosystem. If your super clear, well-structured content earns a strong citation on one platform, say, ChatGPT really likes it.
That mention acts as a signal.
It acts as validation. It increases the perceived authority and trustworthiness of that content piece, which then makes it more likely to be discovered and cited by other AI systems like Google AI Mode or Perplexity or others.
So getting cited in one place helps you get cited elsewhere, a reinforcing loop.
Exactly. You build momentum. The goal isn't just one ranking or one citation, it's to become a trusted, frequently referenced node across the entire network of AI discovery tools.
And the combination of that 62% fragmentation and the hyper-efficiency of these new score agents, what does that mean for good content?
It means authoritative, crystal clear, well-structured content will get found, replicated, summarized, and shared by these efficient agents faster and cheaper than ever before. Clarity and verifiable structure are the currencies of this new era. #HackOutro.
Okay, let's try and wrap up this deep dive. We've covered a huge amount of ground today, really peeling back the layers on AI and SEO.
We definitely have. The starting point was that stark reality, the 62% disagreement gap between major AI platforms. It means you have to think multi-platform.
And you need new ways to measure visibility in that fragmented space using those proxy metrics like SVR, UAVR, and RCC to diagnose what's happening.
Then we went under the hood to hybrid retrieval, seeing how reciprocal rank fusion, RRF, is the mechanism trying to balance traditional keyword relevance with deeper semantic understanding. Structure matters immensely there.
And the engine driving it all is becoming incredibly potent and efficient thanks to frameworks like score agent training.
Yeah, that ability to distill the reasoning power of giant models into smaller, cheaper ones using mentored problem solving and clever RL, that changes the economics of AI deployment fundamentally.
Which brings us to the path forward for creators. A relentless focus on structure, clear claim evidence blocks, solid technical SEO with anchors and schema.
All designed to eliminate that semantic ambiguity that trips up machines, making your content the safest, clearest choice for citation.
We used to obsess over rankings, right? Because that was the visible metric. That was the scoreboard we could influence directly.
It was what we could see and measure easily.
But considering the efficiency gains you described, especially with score agents making powerful reasoning so much cheaper, it leads to a final kind of provocative thought, doesn't it?
Where does this ultimately lead?
Well, if these small, capable, efficient agents are going to be deployed everywhere, not just in the big search interfaces, but maybe embedded in tools, in workflows, everywhere.
Then maybe the ultimate goal of SEO, or whatever we call it next, isn't just about getting that single click from a Google result anymore.
What if it's about optimizing your content to become the preferred, the verified, the most reliable training data for that next generation of widely deployed LLM agents?
That's a profound shift. When your web page isn't just a destination, but it's actively serving as a teacher, shaping the foundational knowledge of potentially millions of AI models.
What does that fundamental reframe mean for your entire content strategy, for your brand strategy? How do you optimize not just for discovery, but for teachability?
That's the question to ponder. How do you become the canonical source the AIs learn from?
Something to think about. Thanks for breaking all that down today.
My pleasure. It's a fascinating, fast-moving space.